Okay, so good morning, everyone. So last class, we have discussed about duty and delta, isn't it? What is duty? What is delta? And what is base period? What is it? What are the different types of crops? And what are the different types of what are the factors affecting duty? All that we have studied. So duty and delta, we have what is duty? The total quantity of water required by the crop. Okay. Duty and delta, the total quantity of water required by the crop for its full growth, may be expressed and unit of duty is hectare meter. Okay, or simply as the depth of water which required for irrigated area if the total quantity supplied were to stand above the surface without percolation or evaporation. Okay, so this total depth of water is called delta, and delta is denoted by this delta symbol. Okay, and one problem is there. If rice requires about 10 centimeter depth of water at an average interval of about 10 days, and the crop period for rice is 120 days. Find out the delta for rice. Delta means we have to find out the depth of water. Okay. Number of watering required 120 by 10, 12. 120 is the crop period and 10 is the depth of water which rice requires to grow. Okay, if you divided crop period by this depth of water, then we will get 12. Total depth of water required in 120 days. It will be 10 into 20. 10 into 12, 120 centimeter. Simply multiply, and for rice it is 120 centimeter. Okay, similar problem is showing here, and let's discuss. There is a relationship in between duty and delta. Duty, it may be defined as the number of hectares of land irrigated for full growth of a given crop by supply of 1 meter square 1 meter cube per second of water continuously during the entire base of that crop. Okay, simply we can say that the area of land can be irrigated for a crop period B in days using cubic meter. So there are some factors which affects delta, and these are type of crops, climate and season, type of crop, climate, useful rainfall, type of soil, efficiency of cultivation method. So these are the factors which duty depends on. Okay, duty means what? The area, and delta means what? The depth of water. Okay, the depth of water required, that is called delta, and duty is the amount, duty is the area that can be irrigated. Okay, area is called duty. So importance of duty, it helps us in designing an efficient canal irrigation system. Knowing the total available water at the head of a main canal, and the overall duty for all the crops required to be irrigated in different seasons of the year. The area which can be irrigated can be worked out. Next, measures for improving duty. There are some measures by which you can improve the duty. Okay. Measures for improving duty of water. The duty of canal water can be certainly be improved by effecting economy in the use of water by restoring to the following precaution and practice: proper plowing, method of supplying water, canal lining, minimum length of irrigation canal, quantity of water. Okay. So plowing should be done properly and deeply so that the moisture retaining capacity of the soil is increased. Methods of supplying water. The method of supplying water to the agricultural land should be decided according to the field and soil condition. For example, in next chapter I am going to give what are the different methods of irrigation. Okay. So one of the method is furrow method. Furrow method for crops sown in iron rows. Contour method for hilly areas. Basin method for orchard. Flooding for plain lands. Okay. So in different crops we have to use different methods of irrigation. Next is canal lining. Suppose this canal is artificial channel-like structure. Okay, so suppose this is your canal. This is your canal. Okay. It is provided to reduce percolation loss in the wall of the canal. Suppose these are the side of the canal. Sorry. Suppose this is at a side, this is one side. Okay, this is the another side of canal. So we have to line the sides of canal properly so that we can prevent loss and evaporation due to high velocity. So to improve duty, we have to do canal lining. Okay. Next is minimum ideal length. It is not ideal, it is ideal length. Okay. The canal should be nearest to the command area so that the ideal length of the canal is minimum and hence reduce transmission loss. Quantity of water. Good quality of water should be used for irrigation. Okay. We cannot use polluted water. Good quality of water should be used for irrigation purpose. Next is crop rotation. Another important point is crop rotation. In last class already we have discussed what is crop rotation, isn't it? Suppose in the same field we have to change the crop, different crops we have to grow in the same field for better productivity rates, for better nutrition, we have to do crop rotation. Okay, that means in the same field we should adopt different types of crops. Crop rotation. The principle of crop rotation should be adopted to increase the moisture retaining capacity and fertility of the soil. Okay. Next is another important point is conjunctive use of crops. What is the definition? It is the quantity of water used by the vegetation growth of a given area. It is the amount of water required by crop for its vegetated growth to evapotranspiration and building of plant tissues, plus evaporation from soils and intercepted uh, partic- precipitation. Okay, it is expressed in terms of depth of water. Consumptive use varies with temperature, humidity, wind speed, topography, sunlight hours, method of irrigation, and moisture availability. So, in mathematical form, we can use consumptive use. This is the mathematical expression of consumptive use, where conjunctive use is equal to evapotranspiration is equal to evaporation. What is evapotranspiration? Uh, do you have one subject? Have you got that subject hydrology? Till now, have you got hydrology? Yes or no?
Yes, ma'am.
You have
Yes,
got
ma'am.
hydrology. Which semester?
Fifth semester, ma'am.
Fifth semester. Okay, I think you have got in hydrology what is evapotranspiration. Already you have learned about it. Evaporation plus transpiration, togetherly known as evapotranspiration. Okay, and consumptive use, it is expressed in depth of water. Next is factors affecting the consumptive use of water. What are the factors which affects the consumptive use of water? Consumptive use of water varies with evaporation, which depends on humidity, mean monthly temperature, growing season of crop, and cropping pattern, and monthly precipitation area. Monthly precipitation area, velocity of localities, soil and topography, irrigation practice and method of irrigation, sunlight hours. Types of conjunctive use. There are three important types of conjunctive use. One is optimum conjunctive use, next is potential conjunctive use, and another is seasonal conjunctive use. Okay, someone is about to enter, but I cannot go to the original meeting, okay? Because I am sharing my screen. If I go return back to the meeting again, return back to the lobby, then what will happen? The recording will interrupt it. Okay, that's why I cannot go. Let me finish, then I will. Some Michelle just now wanted to come in. Okay, so optimal Optimum consumptive use is, it is the consumptive use which produces a maximum crop yield. Next is potential consumptive use. It is sufficient moisture. If sufficient moisture is always available to completely meet the needs of vegetation, fully covering the entire area and resulting in evapotranspiration, is known as potential consumptive use. Another type of consumption is seasonal. Okay, you can study this classification, you can roughly, okay, not so much important. Next is another important term, another important term is crop water requirement. Okay, which is there is a relationship between soil, water. Okay, this is very important. Crop water requirement. Okay, which is also called soil moisture. Okay. Okay, so we all know that below the ground there is a ground table, and there are waters below the ground table, isn't it? So water present in the soil may be classified under three heads. What are the three types of water? One is hygroscopic water, capillary water, and third one is gravitational water. Okay, so let me show you in figure. So in this figure, suppose this is your ground. Okay, this level is your ground. Below the ground, immediately below the ground, there is the water which is available is called gravitational water. Again, next zone of water is called capillary water. Okay. Again, below the capillary water, the water is called hydroscopic water. Okay. Or it is all in this dotted line, there is a dotted line here in between capillary water and hygroscopic water. Can you see this? This is called the wilting coefficient. That means at this point the plant cannot grow. Okay, so this is called wilting coefficient. So this is the location of water: gravitational water, capillary water, and hydroscopic water. Wilting coefficient and hygroscopic water, this is called non-available water, and this capillary zone is called available water. Superfluous water is called gravitational water, is used by the plant generally. Superfluous water it is called. Okay, so let's see the definition. Hygroscopic water, water attached to the soil particle hygroscopic water. Water attached to the soil particle through loose chemical bond is termed as hygroscopic water. Thus, water can be removed by heat only, but the plant roots can use a very small fraction of the soil moisture under drought condition. Okay? Capillary water. The capillary water is held within soil pores due to the surface tension forces against gravity, which act as the liquid vapor or air-water interface. And what is gravitational water? Gravity water is that water which drains away under the influence of gravity. Soon after the irrigation or any rainfall, the water remains in the soil and saturates the soil, okay, thus preventing circulation of air in the void space. This is called gravitational water, which is left to the soil immediately after irrigation or rainfall. That is your gravity water, okay. Okay, there are some important points, important relationship between this water. Available moisture for the plant, Fc minus phi. So in the figure, you can see soil moisture, wilting point and groundwater. This is impervious layer. Intermediate zone, capillary zone. So moisture content. All of you know what is moisture content? Do you know what is moisture content? What is moisture content? This is related to soil. Anyone? Bemisal, can you tell me what is what is moisture content? Can you tell me what is moisture content? Okay, no need to check Google, okay. Moisture content, optimum moisture content, and in between non-available water. Non-available water is also called hygroscopic water. See this point. Non-available water is also called hydroscopic water. So in between optimum moisture content and non-available water, there is a fill capacity. And this area, this point is called wilting point. Okay, this is the available water. Available water is this portion. Next, readily available moisture for the plant. Fc equal, what is Fc? That is the fill capacity minus MO. Fill capacity okay, one definition is left, I think. Fill capacity is not given here. What is the definition of fill capacity? Actually, from the figure you can, okay, here it is. So here Fc is the fill capacity and phi is the wilting point or wilting coefficient. Below plant cannot survive. Okay, so wilting point is that point below. If the water level goes below the wilting point, that the plant cannot grow further. Okay, wilting point is the lowest point in the water level. If water, that means water falls below the wilting point, the plants cannot grow. Okay, that is your wilting point. Next is frequency of irrigation. Remember the definition. frequency of irrigation, weight per readily available moisture depth divided by consumptive use of water. Next, this one is important, field capacity. What is field capacity? It is the ratio of weight of water stored in soil of unit area divided by weight of same soil of unit area. Okay, where weight of water stored in soil per unit area is given by gamma W dW dot 1, and weight of soil per unit area is gamma D into L. dW is the weight of water stored in a root zone. Okay, and what is the dW? Depth of water, gamma by D. This is the relationship between fill capacity and depth of water. Okay, dW equal to gamma dot D divided by gamma W into Fc into gamma Y. Fc into gamma. Next, available moisture depth. That is given by dW equal to gamma D. So you remember the relationship between fill capacity, moisture depth, water depth. Okay. Again, another important point is, already I have told you what is duty, what is delta, and base period. So there is a relationship between delta, base period B, and D, duty. Duty is given by D. So delta, B, and D. There is a relationship between duty and delta. Delta is equal to 8.64 B divided by D. That means delta equal to 8.64 into base period, B is the base period, divided by duty. If you have to find out the duty and delta, suppose base period and delta is given, you have to find D, then you have to use this formula. Okay, where D is the delta and D is the duty in hectares per cubic, delta is in meter, and B is the base period in days. Also, another relationship is delta equal to B divided by D. Okay, next we have some relationship between irrigation requirements, consumptive use, net irrigation requirement, field irrigation, gross irrigation, and then we have methods of determination of evapotranspiration. What is evapotranspiration? It is the evaporation plus transpiration. Transpiration is done by plant. Transpiration is done by green pigment in the leaf. Okay, so evaporation plus transpiration togetherly known as evapotranspiration. Okay, remember. So there are some measure or uses methods. There are some methods to find out the evapotranspiration. One is direct methods, or you can say field methods, empirical method, and pan evaporation method. Okay. So in this method, field observation, indirect method, that is the field method. Okay. So in field method, what we have to do? In a field method, observations are made and physical model is used for this purpose. This includes vapor transfer, field plot method, tanks, lysimeter, integration method, irrigation method, and inflow outflow method. Okay, so these are the direct method, or you can say field method. Remember this. Paper transfer method. So we have details in this method. You can study yourself these methods. Okay, so I will share these notes to you by today evening. Then you will study yourself. Next class we will start different methods of irrigation. Okay. So methods of evapotranspiration, you have to study yourself. Okay, so all of you write your enrollment IDs in chat box. All of you write your enrollment IDs in chat box. Anyone left? Anybody left? So 30, 29 student 1, 28 student 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20,
Hello,
21,
ma'am.
24. Yes.
Hello,
25, 26, 27. Yes.
ma'am.
Yes. Ing TP. What happened?
Yes, ma'am. Actually,
You
I
are
could not
present.
write in everyone chat, ma'am.
What is your roll
Yes,
number?
ma'am. I'm present.
Roll number.
Oh, 117. 117.
117. Okay. So 117,
Yes, ma'am.
right? Okay.
Yes, ma'am.
Okay, then you can leave.